Today we're going to talk about section 6.5, which is variation. Variation is covered in this chapter because an inverse variation is a hyperbolic relationship. So we have different kinds of equations that go with variation. And what we say, we write these equations and we have y equals kx, for example. This is a direct type of variation, and we say y varies directly with x. K is a constant of variation. It tells us, it's like the slope of the line, and it tells us that y is always a multiple of x. So that's direct variation because y is always a multiple of x. You can have a variation that's not linear. You could have y vary directly with x squared, and you would write it like this. And you could have even other things. Y varies directly with the sine of x, and you would write it like this, or something. The direct variation means there's this constant of variation that it's a multiple of. You can also have what's called inverse variation. And inverse variation is the one that's a hyperbolic relationship because it looks like this. Y equals k over x, and you say y varies inversely with x. The reason this is a hyperbolic relationship is, let's say our k is 1. Well, we'll get this type of a picture. That's a hyperbola, but it's rotated on its side a little bit. That's why we're looking at that. Then the last type of variation is called joint variation, and that's y equals kxz, and that's where you have y varies jointly with x and z. So this has more variables in it. These are the two we're going to use the most, the direct and the inverse variation. You need to be able to deal with these in word problems, especially if they say, the height of the mountain varies inversely with the slope of the trail or something like that, then you need to be able to recognize that's an inverse relationship, and you need to be able to set up an equation like that. So let's try a couple of examples. Let's say if y varies directly with x and y equals 21.75 when x equals 8.7, and we want to find y when x equals 12. Well, I said they vary directly, so that's direct variation, so that means I have y equals kx. In these equations, what they're going to do is they're going to give you something that you need to find your k first. Then once you find your k, you'll be able to find the other variables. So this first bit of information here gives us what we need to find our k. So we fill this in, and we have 21.75 equals k times 8.7. So we just simple algebra, divide by 8.7, and we get k is equal to 2.5. Then we can plug that back in, so we know that the equation for this particular relationship is y equals 2.5x. So when we have x is 12, what's y going to be? Well, y is going to be 2.5 times 12. So that means y is 30. Now, if we have, let's try a different one. But if I say if y varies inversely with x, so we know it's an inverse relationship, and y equals 50 when x equals 2.5, and we want to find y when x equals 20, well, it's an inverse relationship, so that means y equals k over x. So the first thing I need to do is find my k using this information. So I have 50 equals k over 2.5. So I just multiply both sides by 2.5, and that gives me k is 125. Then I plug that in over here. So for this particular relationship, I know that y is always equal to 125 divided by x. So if I want to know what it is when x is 20, y is 125 divided by 20. So y is 6.25. So that's an inverse relationship. Now, it's pretty basic and easy. Make sure you realize just some terms like the k is the constant of variation, and this is an inverse relationship. Remember what a direct relationship are, and what they, how they vary. You will have word problems with this that talks about different things, how they vary. For example, you'll do something that says that Kepler's third law of planetary motion states that the squares of the sidereal periods of revolution of the planets are directly proportional to the cubes of their mean from the distance, of mean distance from the sun. And so you have to write an equation for that. It's a direct relationship, a direct variation. So make sure you've read this section and gone over this and taken good notes so that you can do well.